a quick video on significant figures. There may be 2 questions on this on your midterm, and there may be a maximum of 2 questions on this on the Regents. Okay? Generally, when you're doing a problem, if you round it to 1 or 2 decimal places, that will be fine, and you do not need to worry about these rules. Okay? First thing you need to know is how to determine if a figure is significant, okay, if a number is significant. So let me give you a number like 0.0301000. Okay? Some of these numbers are significant and some of them are not. Okay? A number is always significant if it does not equal to 0. Okay? So number 1 is that it's significant if it's not 0. So that 3 and that 1 are significant. So we have at least 2 sig figs in this number. At least. And I'll write that. It's not 2 sig figs. There's more. But it's at least 2 significant figures. All right. The next rule is if it's a sandwiched 0. That means zeros between 2 non-zero numbers. Okay? So I call them sandwiched. And a sandwich 0 looks like this. This one right here in the middle. That is a sandwich 0. If it's a 0 between 2 non-zero numbers, and I'll write that down for you too, between 2 non-zero numbers, that's not a hashtag, that's numbers, it is significant. So I now have 1, 2, 3. I do not have 2 sig figs. I guess I can erase it since I'm on a smartboard. I have 3, at least 3 sig figs, maybe more. All right. The last case is a trailing 0, and I'll show you what I mean by trailing. That means towards the end of the number. End of number. And there is a decimal point. Okay? If it's a 0 at the end of a number and there's a decimal point, it's significant. If it's so the trailing zeros here look like this. These 2. They're trailing because they're at the end of the number. So if I started at the right and I hit zeros going towards the left, those would be trailing zeros. These, and I'll underline them in a different color, these right here are leading zeros. That means zeros in the front of the number. Okay? The trailing zeros are significant in this case because there is a decimal point anywhere in the number. There's the decimal point. Okay? Because I have a decimal point anywhere, those become significant, and I have 5 sig figs in this number. Leading zeros are never significant, whether there's a decimal point or not. So these 2 zeros that are outlined in blue, just because there's a decimal point in between them, does not mean they're both not leading zeros. They're both in front of the number, decimal point or not, and they are not significant. So this number, 0.030100, has 5 sig figs. Okay? A number like 1,000 only has 1 sig fig because these are trailing zeros, but there's no decimal point. So this would have 1 sig fig. SF is sig fig. However, as soon as I do that, and I put a decimal point, this now has 4. Okay? If I add a, 0 there, and now has 5. Okay? Leading zeros are never significant. Trailing zeros are significant only if there's a decimal point. Scientific notation, if it's 4.1 times 10 to the 9th, the only significant part of this number is this. This is just magnitude, okay? So this has 2 sig figs. If it was 4.10 times 10 to the 7th, this is the only part, and it would be 3 sig figs, because this trailing 0 is significant as there is a decimal point, okay? Adding, multiplying, dividing, adding, and subtracting. Here's multiplying and dividing. Here's adding and subtracting. Multiplying and dividing, you round your final answer to the number of what you started with. So I'm going to call it the argument, okay? What you started with, the argument with the least number of Sig Figs, okay? I'm going to round it to the one that has the least. We always get less precise. And if that is something that, if you remember nothing else, we get less precise. Kind of like you're only as strong as your weakest link. You're only as precise as your least precise instrument. Excuse me. Okay. So if I have numbers like 3.3 times 4.172, okay? Punch that into your calculator. 3.3 times 4.172. My answer is 13.7676. Okay? Now, I'm going to round the answer to the number, to the argument, to the one of these that has the least. So, this one has 2 sig figs. This one has 4 sig figs. So I'm going to round this one to 2. 2 wins, because it's less. So this would not be 13.7676. The correct answer would be 14. Okay? Because the 7 makes the 13 round up 1. Okay? Division is the same way. If I had 3.31 divided by 2.8, 3.31 divided by 2.8, my answer is 1.18, etc. I would round it to the one with the least. This has 3 sig figs. This has 2. I'm going to round this to 2 sig figs, which is 1.2. All right. Adding and subtracting, you round your final answer to the least number of decimal places. So when we do this, we kind of like to line them up, all right? You have 2.78 plus 14.2. Okay? Do the math as you normally would. I'm going to put this into my calculator because I don't want to do mental math this early. And I get 16.98. Okay? I'm going to round this to the argument that has the least. Not sig figs. They both have 3 sig figs, but decimal places because adding and subtracting are different. Okay? This one has 2 decimal places. It stops being significant right here. This one stops being significant right there. And those aren't decimals. That's just like how I'm indicating where they are. Let me rewrite that 2 and fix that 8. So what I suggest you do is draw a line down where they both are significant, okay? Where they both, the place furthest to the right where they're both significant. And then we round to this place right here. The 8 kicks the 9 up to 10, and this becomes 17.0, okay? That's the place you would round to, the 10th place, because that is where they are both significant too. Even if this did not have, this is the one that bothers everybody, and I don't think, you won't be asked this on the midterm, and I don't think you'd be asked this on the Regents, but if you had 3,600 plus 100, okay, these are both significant to here, all right, because they don't have decimal places. Even if this was 3,600, I'll write it again, to 50. Add them together, 3,650, okay? 3,600 stops being significant right here, okay? Right here. So that's the place you round it to. It doesn't mean that you ignore the 50 altogether. It means that that's the place you round it to. So I would round this to the hundreds place here, and this would become 3,700 with proper sig figs. okay? Places of significance. So it's kind of not quite decimal places, it's more places of significance. If you don't understand that, memorize it, okay? Just memorize it. But this 0 here is not significant. So 3600 is only significant here and here. 50 is only significant here. So 3600 stopped being significant earlier, okay, than 50. So we err on the side of less precision.